Let's continue system design concepts. So today we are going to talk one of the highly nowadays most popular software development style, you can say, yeah, architectural style, that is known as a microservice architectures. Okay, so in last couple of sessions we have discussed different style or patterns or architectural style to build our applications or systems. Initially we talked about the monolith architectures, and in parallel talks modular monolith architectures, then we talks service oriented architectures, and today we are going to talk about the microservice architectures. Okay, so these development application development styles or approaches are evolve year on year the experience of the software industries. So initially we start building the one monolith applications, every feature, everything's on under one and one database. Okay, this is the initial approach. Then we decided, no, can we move to the modular approach? Yes, we have decided different module in this application itself and our database itself. Okay, and later part again we move to the service oriented architecture. Instead of this, we make a different services, independent services can be deployed, can be run, and they are finally communicate to each other over the enterprise web. And nowadays we are going to further, that is a bigger piece, break into the smaller piece break into the again independent smaller module, and now we again going to the break smaller to smaller as possible, one smaller components. So nowadays almost whatever the new designs are going to build, as of now today we are using the microservice architectures. And once our day are going to evolve coming years, and after a couple of year or decade, new styles of application development can come in the picture. So in this, you can say, in the software development industries, every year something going to evolve new way to deliver our software, right? So you cannot say anything in the IT industry and a fixed and for the permanent, no, because as our IT industries getting more experience of the developing software, developing systems, integration between the systems, we learn more. And nowadays with the help of the hardware industries and software industries, both are evolving. Due to that, our hardware system or software system both are evolving with the help of his past learning and experience. So as of now today, maybe microservice is the very best architecture to build application, but maybe after 5 years, after 10 years, maybe new architectures, new style pattern come, we learn. So please be ready for the change, because the IT industries continuously evolving ourselves, a continuous basis are changing. This change is in IT industries not the only case. Even every industries or the business continuous base, each 5 year or 10 year or decade, you can say something drastically change. This change is come from the nature itself. You notice nature, everything's continuous basis are changing. Even we, our bodies, continuous basis are changing. So even you can say consciously you remember or you observe your bodies. As per the medical science, our body completely transforms the new body after 7 years. Our every cells before the 7 year was the dead, and new cells was replaced with every cells of my body. So every 7 year our body have a drastically change happen. So this is not happen within one day, but continuous, every moment in my body changes going on. So any industries, similarly in the software industry, whatever we are learning today, as of now, today it's fit and fine. Maybe after 10 years, after 20 years, might be this have a absolute and some new development way, new styles come, right? So let's talk one of the best, can say best fit as of now, the microservice architectures. So what microservice architecture means? As mentioned, there are two terms, micro and services. So as of now, we discuss services means business capability. Micro means as small as possible. So whenever we talking to the customer, and customer have a very big use case, and big use case, you have identified some as small as possible different services. So you can again, this microservice architecture also is a software development techniques are that say structures of application as a collections of small independent services. So this is the one methodology or technique where we are going to build our applications not as a complete whole one single modules or one single application. Instead, we are going to break customer requirement as small, and we can build a small application, one very small application for a specific use case and a specific our database. And this is the independent one small application can independently test, can independently deployed, can independently scale. Whenever you are building one big use case of a specific customer, and you have decided this is breakable into the 4 or 5 services, these 5 independent services you are going to the build, they are maybe in the own database, own everything, they are build and communicate with each other as needed, and finally they meet the customer use cases. So instead of building complete applications, we are divided our business use case in a small sub use cases, some business capability, some business functions, and build independently. You can say, as whenever we are studying in a school, in the college, we are building small applications like student management system, enrollment management system, something very small applications. I mean, one or two use cases and a specific database, and complete independently any my local machines and my local laptop I deployed and test. So nowadays microservices, same concepts you apply for the enterprise applications. So don't think complete application you are building in a one chunk. Just let's build a smaller part independent, so a small number of team, different number of teams can work together. So here say each microservice is responsible for a specific business capability. So we have to ensure that whenever we are breaking our business with a smaller subdivision, they meet some specific business need. And that can be those business capability, a business use case that can be developed, tested, and deployed independently of the other services in the application. Let's in your application you have decided the my 4 services. The 4 services, there is no direct dependency. This can be developed independently, and independently can be deployed, independently can be tested. Similarly, this can be independently deployed and test. This can be independently deployed and test. This can be independently deployed and test and develop. So sometime you want to make a communication between these, then we have to also inter microservice communication also happen. Okay, will talk. And similarly, might be our applications we are building for user interface, maybe our front-end application, they are going to interact with the help of, whenever you talking, generally each microservices we are building, they are accessible outside using the API, application programming interface, that REST API. Then we talk the whenever you build the multiple microservices, they expose the multiple interfaces or API. So as of now, before we talk interfaces, now say API, application programming interface, or a REST API or gRPC API. These are lots of terminology we are going to talk. But now once each and every microservices expose how someone can interact with me, how someone request me, how I can respond me. This request and response with going to standard definition, that is the REST definition. The generally microservice are applications we are using the REST designs architectural style. REST have some specific pattern how you can expose your API, maybe get API, post API, REST API, put API, update API, delete API. So each and every microservices, they are going to communicate to other microservice or applications via the API. API can be REST implementation, API can be gRPC implementation, multiple modes of API can be implemented, right? So now once you develop multiple microservices, you have to expose your communication channel for the other application, for the other services via API. So we have build the huge modules of microservices. So you have exposed lots of API. So for managing those API, we need the one API management tool, API management technology, API management system, so that they know, hey, which API are exposed by which microservices, which API exposed by which microservices. Due to that, in the microservice environment, generally we talk about the some API gateway. API gateway is the one tools that make API management. Okay, so we'll go to talk. So microservice is nothing new, nothing fancy, just you are going to build as small applications or services that can be independently one specific requirement, one specific business use case, one specific database. They are developed, they are built, they are tested, and they are deployed independently without need of whole application deployment. Okay, so this is the one of the key benefit of the microservice environments. Each microservice are independently deployed, independently restored, independently scale, right? So let's talk some basics concept in the microservice environment. Whenever you are building microservice environment, these are the basics terminology automatically you have to meet. By default, microservices are the loose coupling designs principle. That means microservice is designed to be loosely coupled, meaning that changes in one services do not affect to the other services. Let's you have decided in my applications you are build 4 microservices. Okay, these 4 microservices. Okay, 4 microservices are independent, so that are used by my front-end applications, right? Okay, so if any times new change requirement come under this service, so this changes is not going to impact any other services. Any other services work as previously working. So if you are changing, some enhancement come, in maintenance come, some defect come, you are fixing, changing one part, one microservice, the other related microservice of the applications are not required to change. This is the only you have to change, you have to test, and you have to deploy it. Even after changing this, even you not required to change other microservices, because you are not going to any impact on other microservices. So this is loose coupling, means ki all the one applications have a 10 microservices. 10 microservices are built independently, but each microservices are talk to each other, but they are independent. Means ki one microservice independently can be shut down, maybe restart, maybe multiple instances, multiple testing, any can happen. So that is the meaning of loose. Generally, the basic concepts of our microservices is the each services are independent, or you can say autonomy. Autonomy means each microservices are responsible for its own behavior and decision, whatever the business capability we are planning to build for one small microservices. So generally, the basic concept of the microservices, whatever the microservice you decide, that's organized around the business capability. We have to we are building microservice for meet one business use case, customer requirement. Customer means business. So those business capability must be met. So you are going to decouple the requirement from the customer in the such way that microservices are organized around the business capabilities, such as maybe payment processes system, inventory management, right, kind of things. Similarly, whenever you are building microservice architectures, your applications are by default enable scaling. Easily your application can be scaled. What do you mean scale? Means now let's see in your one applications you have built 4 independent microservices. 4 are deployed, and notice that maybe this is your inventory management systems or product catalog system. So here our from our API gateway, lots of requests come on by searching on a product. Maybe this is a payment processing system. Payment processing system, maybe less number of requests until 5. So here notice here our one system's heavy load come. The particular festive season, lots of people going to just search the list of product. So this system have a very heavy load due to the maybe performance going to degrade. So what we can do, we can scale them. You can install more and more in your inventory systems, so that our request can be distributed. Even I don't need to increase the scale the processing product increment decrement product capability. They are still continue with a single instance, but the specific microservices that have increased the user traffics, we can then add more server for specific microservices. That means you can scale your applications. Any microservices, if you want, they can scale because they are independent to other microservices. So by default, this scaling system design concepts by default, if you properly implement microservice architecture, you will get. And here one also more different concept than other, decentralized data management. What do you mean with that? That means let us your applications, you have built the 4 microservices. Okay, you have built 4 microservices. So generally previously we are building only one centralized database. All microservices are directly or indirectly are communicate to the centralized database. But this microservice architecture say it is not mandatory. Even each microservice can have own database. They are not going to the talk to the each have a own database. So now microservice architecture more emphasize don't use the centralize the data management. Instead, database management also be distributed, because this is the specific business capability. The specific business related data go to the specific business related database. So each microservice generally have a own database, because each business capability have a different nature. and according to the business nature, maybe you can select different database. The nowadays in a big industries, big applications are generally not using only one database. They are using the multiple database. Why? Because each microservice is designed for the different purpose, and to meet the different purpose might be required different kind of database. Some are the relational database, some are the non-relational database, some are the key value database, some are the graph database, some are the document oriented database. So nature of the business, you have to choose the right database. So here microservice architecture allow us, we can design each microservice with his own database. That means that they are going to focus on a decentralization of the data management instead of the centralized. Right? So these are the basics concept in the microservice architectures. And whenever we talk the basics, some more point about this microservice architectures, as we mentioned, there are a couple of additional things you are going to talk in the microservice. As when you are building multiple services, multiple microservices. So somehow again you need a kind of a service registry mechanism. So service registry is used to manage and keep the track of all the services. Okay, so at least my application, these are 10 services where they are deployed, what are the different details are managed by the microservices, our service registry. And second, now each microservice are exposing lots of API to communicate to each other. That somehow we need some API management tool, that is the API gateway. So API gateway is used to handling incoming requests and route them to appropriate microservices. Okay, and similarly microservices, each microservice is a separate application that provide the specific business capability. That's good. And the data storage, each microservice, as I discussed, the own database, so they're responsible to manage own data. And even we are use the load balancer. Load balancer responsible to whatever the user traffic of in my system. If traffic is very heavy, they are distribute the different subsystem. So generally if you are building any applications, that's applications used by the millions of user, that means your applications are accessible by the across the geographical location. In those scenario, you want to distribute the user traffic to the different clusters of server. So for those scenario, our microservice architecture, somehow some applications we use the load balancer, somewhere use the application gateway, registry, and these are the basics, some points for the microservice architectures. So let's talk some use cases, because these are the very commonly used. So lots of, you can say, the use case where this microservices architecture suit for that, like generally whenever you are building any e-commerce platform or any social media platforms, that's generally nowadays built on the basis of microservice architectures. Okay, so even your e-commerce application or social media applications or any kind of where the users are inputs are very highly, you can say. So here for e-platform like maybe e-commerce platforms where the different services are need to communicate each other to meet the business order management, inventory management, handling payment system, hand entry, shipping management. So generally these whenever one like e-commerce platform, we have multiple services. One your products, or one is your search capability, one your order of the product. One is the payment management system, one is the inventory management system, one is the shipping management system. So lots of independent business capability can required to build. So all this business capability you are going to build as a independent microservices. Similarly, generally real-time analytics applications where the microservice can be built to real-time analytics system that process the large amount of data even. So generally all the content management systems where the customer going to submit our contents, different nature of content, generally we can build the microservice used to build the content management system, provide the personalized content to user specific. And generally where the you are receiving the continuous data generated by the system like IoT devices, where the microservice can build to IoT system that process large amount of multiple devices of the data. So lots of use cases just we have to cover here, very some use case scenario. Whenever you are building or apply the microservice architectures, your application by default get these benefits, you can say, like your system is highly can become scalable easily, just required couple of configuration, and you can say my architectures of the system is highly scalable. Generally microservice scale independently, allow more efficient use of the resources, and even you are allowed to your system should be flexible, because each microservices, let's say we have decided okay, I'm going to build a couple of microservices. Let's say I'm going to build a couple of microservices. Each microservices you can build in the different programming language, different application framework, different databases. So now they are given the more flexible options. One team can work on the different language, different database. One team can build the different technology, different programming skill, different styles, different framework, anything. So now microservice architectures provide the more and more flexibility to choose technology, choose a framework, choose a database for each business capability in the different manner, right? And similarly your application become a resilience. That means if any fault happen, managing it, one service fail and this continue other to operate, because here you are not building whole as a one single application. In anything fault happen, you are going to stop. No, you are independently multiple applications are running the different environment. If one application is crashed or stopped, you have an option, other application is still working, and you can again start the new instance of that. You can start the new instance of that. Your application still manage the fault tolerant. So that means if your application are managing fault tolerant, that means you can say, hey, my application is more reliable or more resilient. So here in the microservice environments, if you implementing, your applications are get the resilience benefit as well as, and even the improved development here deployment, because here lots of microservices happen. So let's one build one independently, you can deploy it, one independently you can deploy it, one independently you can deploy it, different tools and technically you can use the deployment. So microservice allow the faster deployment of the new features and update, and each microservice can be deployed independent to each other. Here let's something new feature, new capability you want to introduce, because if this is the new feature and they are, you can build the new microservices, new database, go independent, deploy in the system. So if any, so here you can say microservice architecture help us to reach customer, deliver customer the particular business use case scenario, be fast, be quick, because you are not going to build whole applications once and deliver, because multiple microservice, multiple team working, already working. Let's just build one specific microservice and deliver to the customer can use them. and even that help us easier to maintenance. Okay, microservice make it easier to maintenance, to update individual service without affecting the entire service. Let some microservice you are going to newer version or change some requirement comes, some change come, you just update a specific, deploy the specific microservices. So here make easier to test, easier to deploy it, because this is the small one microservice. Any new engineer come and understand the small use case and figure out the problem, possible bugs in the system, fix them and deliver them. So if your application is small, this also help for the development team. They can easily read the code, understand the code and figure out where is the problem, or they want to add more feature, they can easily add, because they have not to understand the complete your business domain, all the module, all the services, because each microservices are independent applications. They are easily, so less code base, a small module, a small scope of the business, so they can easily understand. Even for me to explain the new engineer in the system, hey, this is the one microservice, this is the specific business capability they are handling, the specific business capability they can easily understand, and accordingly they can quickly become a deliver our systems. And even this kind of architecture help us reduce risk. Whether if one service experience issue won't worry the entire system. So due to the fault tolerance, or you can say we can somehow our microservice help us to reduce the risk. We can, if something fault happens, something wrong happen, we can replace with the new entirely systems. But there's still lots of advantages, benefit. We talk about the microservice architecture. So always my thumb rule, in the any industries, in anywhere, everything have a double coins. One have a specific scenario, a specific applications that have a good, but some specific situation, a specific scenario that have a not good. So any one thing is not fit for all. Okay, due to that we learn lots of technology, lots of languages, lots of databases. Why? Because one thing is not fit for every scenario, every situation. So similarly, microservice architecture is not fit for each and every kind of application, each and every kind of nature. So there are some kind of challenges, some kind of limitations we have to understand. So there are some challenges and limitations in the microservice architecture, like complexity, because now if you have only one application, you can easily manage, easily deployed. But if you have multiple microservices, so lots of challenges come, like introduce the complexity, like multiple services need to communicate to each other. How the communication happen between the microservice? When the communication happens securely, any data transfer failure, or any network failure, any router failure, any our kind of security breach happen between the network communications. So these are the additional complexity added to your system, and major the problem with also distributed the transactions, because each microservice nowadays have a own database. Each microservice have a own database. So how to maintain the atomicity at transaction? Let's see from the customer perspective, they place they are going to the two transactions. One transaction commit to this database, one transaction commit to this database, one transaction commit to this database. Okay, so when this service call happen, okay, this service call happen, okay, and once this service going to the call happen, this database sum to the constraint, some primary issue, some foreign key, some business rule regulation, something they are saying, hey, this transaction cannot be success, it's a failure. So when this is a failure, this is very hard to again roll back this data changes, roll back this database changes, and tell the customer, hey, something what happened. So we have to think, put some extra effort, extra business logic to maintain the distributed transaction. This is the one of the major drawback in the microservice, the distributed database. Here we can, if we have only one database, we have lots of benefit, like your transaction benefit, your asset benefit, you have auto rollback facility, you have also kind of a joining, fast query accessing. So lots of this joining of the data, making relationship, acid property, these are the some level of complexity or additional steps, additional business logic, additional system required to build to manage the distribution database transaction management. So this is the one of the key you can say challenges as a microservice architecture designs. We have to keep in mind how we plan to address this distributed transaction management. And also, if we have a distributed database, so might be we have a chances of the data consistency problem. Maybe some database are automatically committed, some are committed, some are not committed. If they are properly rolled back, these are properly rolled back, some of this is not rolled back. So somehow our business, from the business perspective only one application, from the customer point of view only one application, but you can distribute in the different databases, so might be chances you have some inconsistent, might be another options here. The different they are read operation, they are read operation, they are read operation, something happen change here, but that are not replicated properly in the different data center. The sometime might be we are reading old data here, the new data. So sometimes you have to take care and plan to manage data consistency. Data consistency has lots of options how to fix, how to address them. Lots of we have discussed how to maintain the data consistency. So here also you face data consistency problem. At that time you have to take a plan how we as microservice architecture designer, how we can address them. And sometime also we face some kind of a testing because our systems are distributed, and whenever on the local developments, sometime we are not able to test all the business use cases properly, because we have one engineer, you are building one microservice, they can test independently API, but sometime they feel excuse me, sorry, so sometime we have to perform some kind of a use case testing, capabilities testing, business process testing. End-to-end testing applications is very nowadays hard, are challenges for the test engineer. Okay, so individual service can be properly changed, but how to operate the integration testing to other microservices. And similarly, we have also sometime put some additional extra care about the security, because now you are putting your data in the different server, different applications, and there might be additional risk about the each services. We have to ensure that the security mechanisms, data security are properly placed. If the data are traversing from the networks over, someone cannot be read, your data should be encrypted. They are going to properly communicate to the specific designated server. So data identity, data security, data encryption, these are the security challenges also we have to apply. Authentication, authorization, and cryptography, additional steps we have to not just secure the only one application, we have to secure the couple of microservices, couple of independent services which are we deployed for the customer. And also additional overload or performance about the communication, because previously only one database, only one application, there is no third party communication happen. Now we have multiple services over the different networks. The here communication channel on the using the internet protocol, maybe within a private networks or the public networks, we have to introduce the additional data exchange between the over the internet. So these are the some, it will take a times. So you can say it will introduce some additional works. You have to plan how each microservice are communicate. We have already discussed multiple communication channel, multiple layers, multiple protocol level communication. Okay, maybe different protocols we have to apply, different synchronous communication, asynchronous communication, directional communication, bidirectional communication. So these are the some additional steps we have to also consider, talk while implementing the microservice architectures. Okay, so that's all are the challenges, all are the advantage, that's good, but still nowadays for us to building microservices, lots of tool technology frameworks available that's make easy microservice development. Nowadays building a microservice applications are very easy, because we have to build very small application. First thing, that is the make developer mind happy. I have to build one specific use case, one specific code base, one specific database. So mentally developer feel very confidence and they become more productivity, because internally they feel confidence. We have to, at this sprint, we have to only take care of a specific small applications, not whole bigger enterprise application. So due to that, and about other than, they have a lots of technology framework available. If for the containerizations, we lots of nowadays application using Docker and Kubernetes. So Docker give us the instance, a node where my applications, one microservice deployed, and multiple microservice can deploy, multiple microservice deploy. Whenever you have a lots of Docker node, you have to manage them to deploy group wise something. Then Kubernetes help us to management of the groups of Docker nodes. Or Docker node means your machine, software, hardware machine, or software machine, virtual machine. Okay. Similarly, for service discovery, lots of open source third-party framework available. Heavily Netflix, Eureka servers are used by the multiple organization company. Apache, ZooKeeper also help us to implement the service discovery in the microservice environments. Similarly, we each microservice are exposing lots of API, so we need the API management tool. This is known as a API gateway. API gateway have a like NG, Linux you can use, Amazon API gateway. Nowadays, all the cloud provider, even the Amazon or Google or Microsoft, Oracle, IBM, all they provide the API gateway. Okay, and similarly, for the user traffic management, we also need a kind of your load balancing. So for the microservice environments, maybe you can use the cloud provided load balancer, maybe Amazon Elastic load balancer or Google load balancer, Microsoft Azure. Similarly, or you can the open source like HA proxy, and lots of, we have discussed load balance, lots of types of load balancer available, and we can easily use them. And similarly, this is the one additional steps are introduced in the concept of microservice, because in a microservice you are deploying lots of the independent your machines are server 1, server 2, server 3. So we have to need to manage the performance of my applications, logs of my applications. Okay, so somehow we need a monitoring tool to monitor health of everything working file, which server is healthy, which are the not healthy, which are the overused, which are the less used, so that if the particular server are overused, then we can add more and more server. If we have already more and more server but there is a no use, less uses, then we can remove the server. Okay, so all this benefits we have. So all this server we have to kind of monitor the health, the performance, accessibility, CPU uses, memory uses, performance of system, performance of hardware, software, everything. So for that we need some monitoring tool. So Prometheus, you can use Grafana. Nowadays these two are heavily used in many applications. Apart from that, more than other monitoring tools available, you can use them, but these are the very Grafana offer the lots of facility that you can view the logs of the distributed multiple microservices as well. Even for the collecting logs and providing the graphical user interface to search and everything view, so you can use the maybe Elasticsearch or Logstash or Kibana or OpenSearch. Lots of open search technology available for us to monitoring the logs and visualizing the logs analysis as well as, right? So these all are the kind of tools, lots of tools and techniques, technology or frameworks available for helping to design application in the microservice architectural styles. And if you look the lives nowadays, lots of industries are the applications or the system already built on the basis of the microservice environment. If you talk about the Netflix already use the microservice architectures to manage its video streaming services, and they have more than over 500 microservices across the globe. Notice more than 500 microservices in under one application, one simple web application, Netflix. Behind the hundreds, more than hundreds of the microservices are placed. Similarly, if you talk the Amazon's also use the microservice architecture to manage its e-commerce platform, and thousands of microservices running under one e-commerce applications, right? And even you talk about the Twitter also use the microservices to manage all the social media platform activities, and more than 200 microservices is still LinkedIn are using. Even you talk about the Uber is also use the microservice architecture to manage its ride handling services, and more than 100 microservices they are placed under the one Uber application. Airbnb application also use the microservice architecture, and here to managing your vacation rental platform systems over the more than 50 microservices. So if you look lots of, I cannot list each and everything, but you can say just explore lots of real world applications nowadays are built on the basis of microservice architectures that they are using. If I talk about the basic architectures in the case of deployment perspective, in the overall perspective, so we have built the couple of microservices, microservices 1, microservices 2, microservices, lots of microservices you can build here, right? And each microservices, but how they are accessed by my client applications. Okay, the generally client applications are, you can say, front-end applications are just user access by my applications, maybe client, maybe application, maybe user from mobile, any client can be. So generally first for managing a traffic, maybe millions of user traffic come on your system, so directly they are not going to your specific microservice. Instead, the first go to the load balancer. Our load balancers is the primarily responsible to distribute the users on the basis of different load balancing algorithms to different servers, clusters of server, you can say. And after that, you notice we have a lots of microservices. Microservice expose lots of API, so we need a API management. So here generally they are route to our API gateway, clusters of API gateway, you can say. Many applications, you can say, clusters of API gateway you can apply, and API gateway are route specific request to the specific microservice specific endpoint. So this is the commonly you can say trend in the microservice environment. Your all the requests go to the load balancer. From load balancer, it's go to the API gateway. From API gateway, then it's go to the backend system or the microservice system. So this is the standard, you can say, deployment, or you can say user request flow happen, or you can say very high level of designs of the system. All the requests go to the load balancer. Load balancer request again route to the specific API gateways, and API gateways route your call to the specific list of microservices. Here notice the 500 microservices are used by your Netflix. So this API management really play a very role, which microservice, which API I am going to route. The API gateway play a very crucial role where you have to manage millions, thousands of the APIs. So our application, our client directly not go to remember call to the thousands of API. So API gateway manage those things. So let's talk about the one real use case about the Amazon micro example. So if you are using the Amazon clouds, they have offered this facility. Whatever the clients you have, maybe you have a desktop clients, maybe your mobile client, maybe your any application third-party client, all the clients requests go to the load balancer. So here AWS already have a load balancer capability, you can use the, and after that your loads are distributed to your API gateway, and API gateway have a lots of capability, just not the managing the API management, even they have some caching mechanism for a specific API. They are requesting specific data, they can use the cache data APIs. So lots of things API. Surely I'm going to talk on more one class for the API gateway, just like we have already discussed the more detail about the load balancer, type of load balancer algorithms, which layers of load balancer I'm going to use here. So similarly, API gateway also is the one of the key concept arise in the era of microservice environments. Okay, so here notice our microservices. Here microservice 1, microservice 2, microservice 3, microservice 4, and each microservices are have own database 1, database 2, database 3, and database 4, right? And each microservices internally also communicate to each other via the maybe gRPC call, maybe HTTP call, REST API, synchronous, asynchronous, right? This is even further, if these microservices may be called or related to the other services, yeah, other configuration, other data, they can communicate. So these are the kind of all the cloud provider provides such kind of architectures where you can deploy your application on the client can interact to the load balancer to the API gateway to the respective microservices. Here for the monitoring, for logging, we have applied some other tool like here Prometheus, Grafana, Elasticsearch, everything you can place. So this is the one of the standard Amazon's cloud provided services you can use to deploy you develop microservice environment. So let's talk some couple of references where whatever we discuss, everything available on the internet, we can just go and explore. This is nothing new which I am going to talking, which everything's available. You can just go and refer and read out. These are the lots of open platforms, contents available about the microservice architecture for the enterprise large scale application. Whenever you have a large scale of application, you can use them. Okay, so generally like a microservice architecture based on the best practices here mentioned, like this is our mobile application, client application, they communicate to the API gateway, and notice might be different microservice, can be catalog microservice, shipping cart microservice, discount microservice, ordering management. Each microservice has their own database. So this is the basic architectures of the clients microservice architectures, right? And even we discuss the like initially we discuss like a monolith application, then we move to the modular monolith application, then we will move to the microservice architecture, and after that even we are going to the move further serverless architectures. I'm going to talk one further classes about what the serverless, but as of now we understand this is the microservice architecture, where we are slowly enhancing our monolith, modular monolith, and microservice before we discuss about the service oriented architecture as well as, right? So similarly, if you lots of things, just you go read out here, everything's mentioned here. And if you talk about the like here in the case of monolithic, one applications, one database, and before the here the microservice, notice we talk about the here, so a service oriented architecture as well as the service oriented architecture have a bigger services and some smaller services, big database, maybe a couple of databases. Microservices again smaller services, and each have a own database, some kind of a visual representation of your microservice architectures. So lots of things on this internet you can just understand, you can just call each and everything's details mentioned here, right? Even let's look the Netflix system design, what are the architectures we have already. I last class also I'll talk how Netflix systems are using the microservice backend architecture, and more than 500 microservices are deployed on the under the one simple web-based application like Netflix system. So if you talk here the backend system, this is the more details. Okay, so here if you talk more details here, these are the kind of systems they have. Notice here whatever the kind of client can be desktop, server, mobile, okay, some. So first go server to their load balancer. Here the Amazon Elastic load balancer, and here also they use the CDN, and after that they are routed to specific the list of microservices, and lots of big technology here. Notice the MySQL database and some different streaming Kafka data, and here S3 Amazon S3, and lots of clusters of gateway, lots of techniques they have used, right? And here though notice the list of microservices they are also using the headers use here. So systems, so even you can read out everything details here why they are using the CDN clients, and this is the basics our backend architecture for the our Netflix. Notice here lots of kind of a client can be user client can be using the individes, and first request go to the our load balancer, AWS load balancer, then request move to the API gateway, and API gateways decide, hey, they are going to the sign up microservice, discovery microservice, pay microservice, lots of API exposed to which API they are going to call, and according to the API management they are couple of your list of microservices or dozen of microservices, yeah, hundreds of microservices deployed here. And here the microservice also use the concept of caching to the increase the performance of system, and after that again there may be some asynchronous processing happen. They are talk to the some Kafka processing, where they are going to store your complete file system metadata and some master metadata, everything's here placed. So overall objective here the complete notice the here the couple of hundreds of microservices, and here the API gateway decide which microservice we are going to call, and users are directly interact to the load balancer interact to the route to the API gateway, and cluster of API gateway you can say, and later part you can go. Notice here even the AWS clusters of the load balancer, if one load balancer fail, another load balancer can be, another load balancer can be. So here you cannot make a single point of failure. It's only one load balancer. What happened? One load balancer is crashed or failed. So Netflix can be down? No. So the where you think this is the single point of failure, you have to make the clusters of the machines. So here you can say AWS provide the clusters of load balancer. So here Netflix are using the clusters of load balancer and cluster of API gateway, clusters of microservices to handle high user traffic requests, right? So these kind of you can say techniques, microservice architecture is the you can say very simple architectures, and this is also suit for your small applications or even big enterprise application. If you want to build, you can be figure out, hey, what the might be list of microservices you can build. Microservices is nothing, just one simple application, a small and simple application. Microservice, just understand, one simple and small application, simple application use case, simple database, and just nothing. And when this simple all the use cases are small, you can develop, and in this case you can develop hundreds of microservices, because many big application, lots of small business use cases. And once you are choose to build microservices style architecture patterns, you can get lots of benefit. Your system by default is scalable, reliable, and but here lots of challenges. You have to plan those limitation challenges as well as. So hope this information give you the very basic microservice architecture. Microservice architecture say keep think as simple. Overall very complex system you are going to build. That's I know customer have very enterprise applications you are going to the build, but that is building not required the lots of complex. Just build as small application, small application, all small applications, all they serve specific use cases, specific, and overall deploy on the different cloud, and finally they meet this complex one customer business requirement. You can meet with just simple small applications. Each how do they communicate, talk, routing happen, semantics nothing, but microservice architecture is a simple approach to build application. Don't build more complicated software. Build each microservice as simple, as small, so that your code, your application can maintainable, and your code can be extendable, enhanceable. In future, new microservice, yes, introduce one more business use case, no problem, because all are the independent. There is no tight coupling between this. Hey, this microservice can be destroyed, no problem. Other microservice still working. We can deploy another instance of the same microservice. You can add more feature, just small one more microservices. So here, for building any enterprise level application, high load application, microservice architecture just say, hey, keep simple. Just build small application, and after that you find, hey, you can solve the bigger problem. You can solve the bigger enterprise application. You can design, you can build the large enterprise scale applications. So microservice architecture is not the very kind of a complex architectures. They tell us, they give us mentally benefit to us. Hey, we have to build a small independent microservices that can be independently built, test, deployed. Even we can choose different programming language, different database, different testing framework, different application framework. For each microservice you can choose different technology, different database, different programming language, different approaches to implement. So they microservice offer lots of flexibility for the development point of view, for developer perspective. And this concept, simple, a small application, make lots of key benefit and advantage. Due to that, nowadays mostly almost larger applications are going to build with the help of microservice architectures. Hope this information is helpful for you. Thank you.